10 minutes of easy walking after dinner burns more belly fat than an hour at the gym on Saturday morning. And once you understand why, the reason your stomach has not shrunk despite everything you have tried is going to make a lot more sense. If you carry extra weight around the middle that will not go away no matter how carefully you eat or how many workouts you push through, the missing piece is almost certainly not your diet. It is not even really your exercise routine. It is whether or not you move your body in the hour right after you eat, because when you sit down after a meal, your body stores most of that food as fat, and when you walk after a meal, your body burns most of that same food as energy instead. In Japan, elderly couples step out for a slow walk together after every single dinner in a small daily habit called shokugo no sanpo, and the adult obesity rate in that country sits at around 4%, while the rate here in the United States sits above 40%. Western researchers are only now beginning to catch up to why this simple habit works as well as it does, and the mechanism reaches far deeper into the body than almost anyone realizes, all the way down into the liver and the exact process that builds the fat around your midsection in the first place. To see why that hour matters so much, you have to understand what your body is actually doing in that window. Most people think of a meal as ending when they set down the fork, but physiologically, that moment is really when the meal begins. The next 60 to 90 minutes is when your body is deciding, in real time, what to do with the glucose and the fat and the amino acids that are arriving in your bloodstream from what you just ate. And physiologists have a name for this window. They call it the postprandial window, and it is one of the most overlooked pieces of your daily metabolism. The idea that weight gain is decided at the moment of eating is one of the most misleading assumptions in popular nutrition, because the real decision is made in what happens next. Two people can sit down to identical meals, and one of them will store almost all of it as fat around the waist, while the other burns nearly all of it as fuel in the legs. The difference between those two outcomes is not the meal on the plate, and it comes down entirely to what the body was allowed to do in the 60 minutes after. The Western default during that hour is to sit down in front of a screen and let digestion happen while the body is completely still, while the Japanese default is to take a slow walk through the neighborhood and let digestion happen while the body is moving. Nobody in Japan ever framed the walk as fat loss, and nobody was told it was a metabolic intervention. It was simply the shape of the evening, in the same way that conversation and tea and sleep were the shape of the evening. And that ordinary shape turns out to be one of the most effective ways to influence body composition ever measured, tucked invisibly inside a completely unremarkable way of living. To understand why, we need to look at the actual physics of what happens to a meal after you eat it. Every meal produces something called a postprandial glucose excursion, which is the rise in blood sugar that follows food entering your system. Your body has to clear that glucose within about 2 hours or damage starts to accumulate in the vessels and organs. What almost nobody is taught, though, is that your body has two entirely separate ways to clear that glucose, and the two pathways lead to opposite outcomes for your waistline. The first pathway is the one that most people vaguely understand, which is the insulin route. The pancreas releases insulin in response to the meal, and insulin then signals your fat cells to open their doors and pull the glucose in for storage as triglyceride. This is what happens by default when your body is at rest, and it is the pathway that gradually builds the fat around the abdomen year after year. The second pathway is the one almost nobody hears about, and it is called insulin-independent muscle uptake. When your leg muscles contract, they open a completely separate mechanism called GLUT4 translocation, in which glucose transporters migrate to the surface of the muscle cell and pull glucose in directly from the bloodstream without needing any insulin at all. The muscle simply grabs the fuel it needs because it is being used. You can think of it as two doors opening in your bloodstream at the same time after every meal, where one door leads to fat storage and the other door leads to muscle fuel. Which door the glucose walks through depends almost entirely on whether your legs are moving in the 20 to 60 minutes after you eat. The scientist who has spent decades mapping this pathway is Erik Richter at the University of Copenhagen, and his laboratory has shown that muscle contraction opens the GLUT4 route within just a few minutes of movement beginning. There is no warm-up requirement, no minimum heart rate, and no need to break a sweat at all. The pathway responds to gentle contraction the same way it responds to intense contraction, which is a fact with enormous consequences for anyone who thinks weight loss has to hurt. So the fork in the road inside your bloodstream is not really being decided when you sit down to eat, and it is being decided instead when you stand up, or when you fail to stand up in the hour that follows. The measurements that pinned all of this down came from a research team at the University of Limerick in Ireland, led by Aidan Buffy, who published a meta-analysis pooling the results of multiple controlled trials on light walking after meals. What his team found was startling even to specialists in the field. Even 2 to 5 minutes of light walking after eating blunts, the glucose peaked dramatically compared to sitting, and pushing that walk out to about 10 minutes flattens the curve almost entirely, so that blood sugar barely rises above baseline at all. The mirror image of that finding comes from David Dunstan and his team at the Baker Heart and Diabetes Institute in Melbourne, whose work on sedentary behavior is some of the most rigorous in the world. Dunstan established that the specific combination of sitting after eating is metabolically far worse than either sitting or eating on its own. It was his research that really refined the popular claim about sitting being the new smoking, because he showed that sitting itself is not the whole story. It is sitting during the postprandial window that produces the real metabolic damage. 10 minutes of easy walking after a meal, then, is not a workout in any meaningful sense of the word. It is a switch. You are not exercising the meal off your body, and you are not burning it away with effort. You are redirecting where the meal goes at the level of the pathway itself, sending the glucose into the muscle door instead of the fat door. That distinction matters more than almost anything else in this conversation, because it explains why so many people can go to the gym 3 times a week and still gain weight around the middle. The gym session on Saturday morning does very little to influence what happens to Wednesday night's dinner, and the fat that is being deposited during those sedentary evenings is being manufactured through a mechanism that a workout simply cannot reach. The only intervention that reaches it is movement inside the specific window when the meal is being processed. To see why belly fat in particular is so tied to this window, you have to understand what your liver does when the muscle door stays closed. When glucose enters the bloodstream after a meal and the muscles do not take it up, blood sugar rises past the point where insulin can efficiently manage it. The liver then steps in as the emergency reservoir, and the way it deals with the excess glucose is to convert it into triglycerides through a process called de novo lipogenesis, which literally means the creation of new fat from scratch. Those newly manufactured triglycerides get packaged into lipoprotein particles and shipped back out into the bloodstream, and a significant portion of them end up deposited as visceral fat, which is the metabolically active fat that wraps around your abdominal organs. Visceral fat is what drives insulin resistance, cardiovascular risk, and the accumulation that most people casually describe as middle-age spread. Research on de novo lipogenesis from teams led by scientists like Jean-Marc Schwartz has shown that the process is extremely sensitive to the size and duration of the postprandial glucose load, which means the longer glucose lingers in the bloodstream after a meal, the more of it gets converted into stored fat around your midsection. Walking during that window short-circuits the entire cascade, because the leg muscles are pulling the glucose out of the blood before it ever pools long enough for the liver to convert it. The fat is not burned off in the walk itself, because 10 minutes of easy walking only burns about 30 or 40 calories in total. The fat is simply never manufactured in the first place, and that is a completely different and far more powerful mechanism than caloric expenditure could ever be. So the visceral fat that so many people are trying to lose at the gym on Saturday morning was largely created on the couch on Friday night, in the hour and a half right after dinner. A 10-minute walk during that window does not burn it off after the fact. It prevents it from ever being made. There is a second effect stacked on top of the glucose one, and it involves your blood vessels. When you walk after a meal, the endothelial cells lining your arteries release a molecule called nitric oxide, which relaxes the smooth muscle in the vessel walls and widens the artery, improving circulation throughout the body. This matters especially during the postprandial window, because a glucose load is one of the most acutely stiffening insults an artery can experience. A spike in blood sugar temporarily reduces endothelial function for hours afterward, which is one of the underappreciated ways that a lifetime of sedentary meals gradually produces cardiovascular disease. Jaume Padilla and his laboratory at the University of Missouri have shown that even short periods of walking during otherwise sedentary time can restore endothelial function that sitting after eating has impaired. So a post-meal walk is doing 2 independent things at once. It is pulling the glucose out of the bloodstream through the muscle door, and it is also keeping the arteries pliable during the same hour they would otherwise be stiffening under the sugar load. 1 habit, 2 protective mechanisms, and neither one requiring a gym membership or a training program of any kind. This is part of the reason that Japanese cardiovascular health outcomes look so different from Western ones at the population level. The typical explanations focus on diet, and diet is certainly part of it, but a meaningful portion of the difference likely reflects a lifetime of the after-meal walk protecting the endothelium every single evening. Millions of people are running an experiment that no clinical trial could ever match in scale or duration without ever thinking of themselves as being in an experiment at all. The population level numbers make this even clearer. Adult obesity in Japan sits at around 4%, while in the United States it hovers above 40%, and that is a gap far too wide to be explained by diet or genetics alone. There are invisible variables doing work in the Japanese daily rhythm, and the after-meal walk is one of the largest of them. Western sedentary behavior research typically runs trials on a few dozen volunteers over a few weeks, but Japan has been running the same experiment on an entire population for a century, and the results are visible in the raw statistics. Look again at the elderly couple walking beside the canal in Kyoto, and you can begin to see what you are actually looking at. It is far more than a quaint cultural habit, or simply the fact that they walk more than we do. It is a specific, targeted, biochemically precise intervention timed to the exact metabolic window in which the body is most vulnerable to fat storage. That intervention is being deployed every night at a population-wide scale across a lifetime. The lean bodies of elderly Japanese people are largely the visible surface of a habit so ordinary that nobody thought to study it until the last 20 years. Let's be honest about where the popular version of this idea starts to go wrong, because it is already being distorted in exactly the ways you would expect. There is a cultural instinct in Japan that leans toward understatement instead of exaggeration, and understatement is exactly what this subject needs, because the truth is impressive enough on its own without being inflated into a miracle. The plain version is that walking after meals is not cardio, and your heart rate does not need to rise for the mechanism to work at all. You should be able to hold a conversation easily throughout the entire walk. It also does not burn many calories directly, because 10 minutes of easy walking uses only around 30 or 40 calories, which is nowhere near enough to matter as caloric expenditure. It will not replace strength training for muscle mass, and it will not replace real cardiovascular exercise for improving your VO2 max. And a single walk on a Saturday cannot undo a full week of sitting after every meal, because the mechanism is meal by meal, and it has to be applied at each meal to produce the effect. The way to think about this correctly is as a signaling intervention rather than a caloric one. You are flipping a metabolic switch at the pathway level during the specific 60-minute window when the switch is available to be flipped, and you are redirecting the glucose from the storage door to the fuel door. Anyone selling this as a Japanese walking method that melts pounds in a week is missing the mechanism entirely. The point was always signaling, applied at exactly the right moment, over and over across the years. So what does an evidence-grounded version of this look like in practice? The timing matters most, so you want to start walking within about 30 minutes of finishing eating, because the earlier you start, the more of the glucose peak you intercept before it builds. Once you get past 60 minutes, the window is largely closed, and the intervention loses most of its power. 10 minutes is the length that the Buffy meta-analysis identified as producing near complete flattening of the glucose curve, though even 2 to 5 minutes produces meaningful benefit, so any movement is dramatically better than none. The intensity should stay easy and conversational throughout, because the GLUT4 pathway opens at low contraction intensities and does not require any additional effort to recruit further. Trying to walk faster does not produce more of the effect, so a gentle stroll around the block is exactly as effective as a brisk march for this specific purpose. The Japanese do not have dedicated post-meal walking routes because they simply walk to the next thing they were going to do anyway, whether that is a small errand or a visit to a neighbor or a slow loop through the local shrine grounds. If you can only manage this after one meal a day, then make it after dinner, because dinner is usually the largest glucose load of the day, and it is followed by the longest sedentary stretch, which is the couch and then sleep. Skipping the walk after breakfast or lunch is not ideal, but skipping the walk after dinner is where the metabolic damage really compounds. A consistent daily 10-minute walk after dinner will produce more measurable change in your belly fat composition over the course of a year than 3 gym sessions a week without it, which is a claim that surprises people until they understand the mechanism behind it. One honest caution worth including is that if you are on any medication that affects blood sugar, particularly insulin, then the same mechanism that helps healthy metabolisms can push you toward hypoglycemia. So you should coordinate the timing with your physician before you make it a daily habit. The bigger picture worth sitting with is that so much of what we describe as middle-age weight gain or stubborn belly fat is not an inevitable biological countdown written unavoidably into the cells. A meaningful portion of it is mechanical, and it is the accumulated result of a signaling deficit built up across 10,000 meals eaten in stillness. Fat cells that receive the storage signal instead of muscles receiving the fuel signal. Livers that manufactured triglycerides, which the leg muscles could have simply burned in a few minutes of walking. Arteries that stiffened under postprandial glucose loads a short walk would have neutralized before any damage began. None of that requires a drug or a procedure or a gym membership. It requires only a mechanical input that the human body was designed to receive, because for essentially all of evolutionary history, we walked after meals, whether we wanted to or not. There was food to gather, water to fetch, a fire to tend, and a camp to move. Sitting still during the postprandial window is a purely modern condition, and our metabolisms have not caught up to it, and they may never catch up to it, because evolution operates on a timescale far longer than a few generations of desk work. The researchers who have mapped all of this out are simply describing a mechanism rather than a mysterious Eastern secret. Buffy and his team at Limerick, Dunstan and his colleagues at the Baker Institute in Melbourne, Eric Richter's decades of GLUT4 research in Copenhagen, Jaume Padilla's endothelial work at Missouri, and Jean-Marc Schwartz on the lipogenesis pathway are all describing the same phenomenon from different angles. That mechanism has been sitting there the whole time, hiding inside an ordinary Japanese evening that nobody thought to measure until recently. What makes this genuinely encouraging is that the muscle machinery stays responsive at essentially every age that has ever been studied. A 70-year-old's GLUT4 pathway opens in response to muscle contraction the same way a 25-year-old's does, because the system does not expire with age. It simply stops being asked to run, and the moment you start asking it to run again, it responds the same way it always did. So here is where all of this lands, on you, tomorrow. After lunch, resist the urge to sit down at your desk or on the couch and take 10 minutes of easy walking, whatever that happens to look like where you are. A lap around the office, a walk to a coffee shop instead of the vending machine, or a slow loop around the block before you sit back down. Understand what you are actually doing while you are doing it. You are standing at a fork in the road inside your own bloodstream and deciding which door the glucose walks through, whether it goes into storage around your waist or into fuel in your legs. 10 minutes of easy movement is enough to close one door and open the other, and that really is the whole mechanism in one sentence. The elderly couple walking beside the canal in Kyoto is not doing anything you cannot do yourself. They just never stop doing it after every meal, every evening, for a lifetime, and the lean and upright bodies you see on those streets are the visible signature of a signal sent every evening across the decades. Your body is listening for that same signal every single day, waiting to be told whether it should send the glucose into storage or into fuel, and the answer you give it depends entirely on whether you take those 10 minutes or stay in your seat. Thanks a lot for watching. And if you want more breakdowns like this one, the kind that hands you the actual mechanism instead of a slogan, then subscribe to catch my next video.